Good morning. In this video, we are going to find the classification of moment of inertia. There are two types of inertia. First one is area moment of inertia. The second one is mass moment of inertia. Before going to the discussion, we have to know what is the difference between these two inertias as well as the importance of them. Okay. In my previous video, uh, I said that the moment of inertia depends upon two important things. First one is the formula. This is moment of inertia depends upon mass as well as the perpendicular distance. Second thing is that it depends upon the distribution of mass. The distribution of mass. This is also I discussed. So this is the second important thing. Okay. So moment of inertia depends upon both formula as well as the distribution of mass. Okay. Let us see in detail. Let me consider two sections. One is a square section and another one is a I section. Okay, both the sections are made up of same mass and same material, everything is same. And if I apply the formula, moment formula, mass, which is mass into r square, this formula, since mass and r are same, this gives the same moment of inertia for these two sections. Okay, that means both sections will give the same answer, same moment of inertia. But in reality, this I section will give you more moment of inertia than square section, because the distribution, if you look at the distribution here, the mass is uniformly distributed, where the I section most of the masses are distributed in the outer end. Okay, so this will give more moment of inertia. So it is used in many of the engineering applications in the railway, etc., etc. So this is the difference between area and mass moment of inertia, and it is the reason why the area moment of inertia should be calculated. Okay, though the mass is same, the distribution of mass play an important role. Now let us go to area moment of inertia. There are two types. First one is discrete system and second one is continuous system. In distribution system, let me take a area A, and which is being distributed from A1 to AN, and it is a finite distribution where we can able to count the number of small areas. Okay, here x1 is the distance between y axis and a1, and in the similar way y1 is the different is the distance between a1 and x axis. Okay, now to find the moment of inertia with respect to x axis, here is the formula: a1 into y1 square plus a2 into y2 square and up to a n y n square. Okay, and in the in simple form it is written as summation of I1 to n ai into y square. In similarly, here the same formula, but in the place of y, here x1 is used, x1 and a1 x1 square plus a2 x2 square plus an xn the whole square, and upon simplification this will become like this. And if you go to a continuous system, okay, where the mass is area is divided, but it is infinitely. Okay, you cannot able to count it. Okay, let me take a small area of that one, and it is located by x distance from y axis and y distance from x axis. Now the formula for finding moment of inertia is, with respect to x axis, it is integration of y square into dA. Y here integration is used means here the number of elements are infinite, but here it is finite. Okay, again with respect to y axis, it is integration of x square into dA. And one more information, this is the second moment of area. Already I told you that first moment of area is used in centroid, second moment of area is used in moment of inertia. We will meet in the next video. Thank you.